Hello, this is Mrs. McTaggart. In this video we are going to look at the questions in the differentiation topic that ask you about maximum and minimum values within a closed interval. Now a closed interval is, instead of basically looking at the full graph of a function, we're only going to look at a certain little window of it. I'm going to give you a certain domain that I'm going to look at, so I might tell you that x is between 1 and 4, so we're only looking at the graph from the x coordinates of 1 up to 4, and from that we're going to be asking what the maximum minimum value is, which is like the maximum and minimum height that the graph goes to. So let's consider this image here. So this is a graph of x squared minus 2x minus 10. We can clearly see that at the moment the minimum of this graph is minus 11, and that occurs down here when x is the number 1. So that would be the current minimum. And the maximum value, okay, from my picture it looks like the maximum value is up here. There is no actual maximum value. Remember, these are continuous graphs, so they will continue to keep going and going. So there is no maximum value until I start to limit this. So consider this picture here. I have limited this now to be between minus 1 and 4. So this is written that x is between minus 1 and 4. So at this point I have a minimum value of minus 11 and I have a maximum of, that looks like a minus 2 to me here, and I have a maximum of minus 2. And they occur when x equals 1 and when x equals 4. So one of my maximum minimum values occurred at my end point, and one of them happened at my stationary point. So to do these questions, basically we have to always look at our end points, and then we have to look for our turning points, because the turning points could be where the maximum minimums occur also. So here is a little bit that I would copy down as a note from teaching this to class. I would remind people to write down that maximum minimum values in a closed interval occur at either endpoints or stationary points. And I've got an example of one here where they're clearly, so my first example clearly has no turning point for that little window of the graph. So the maximum would have been when x is 4 and the minimum would have been when x is minus 5. On example 2 here, you can clearly see that although I've used the midpoints, the endpoints 3 and 4, the lowest value actually occurred down here at my stationary point. So we always have to find our stationary points as normal. So maximum and minimum now is another buzzword. When you see that, that's to remind you, oh, well, we need to differentiate. It's a stationary point question. And then what we're going to do is we're going to find our stationary points and we're going to sub in the x's to get the y values. And then we're going to sub in our endpoints as well. And then it's literally a case of finding the highest and lowest answers. So let's have a look at an example. So for this one, we have to find the maximum and minimum values of this function. So the first thing I'm going to do is I'm going to rewrite this so I can differentiate. So this would give me 4x cubed minus x to the power 4. So if we differentiate this, this would give us 12x squared minus 4x cubed. Now we want to find our stationary points. So for our stationary points, we're going to set f dashed x equal to 0. Now this is a common factor of 4 and an x squared. So 4x squared removed leaves you with a 3 take away x, and we're putting that equal to 0. So we have stationary points x equals 0 and another stationary point of x equals 3. Now both of these numbers are okay to use as our stationary points because they both lie between the minus 1 and the 4. So be aware sometimes though, and you'll see it in my next example, sometimes your stationary points actually fall out with the limits I've given you to plug in, okay? So out with our end points. So what we do now is we're basically going to sub in our end points and our stationary points. And I'm just going to start with the stationary points ones. So I'm going to work out f of 0. So this goes back into our very original equation. So I'm actually going to plug back into here because I think plugging in there is a bit easier than plugging into 4x cubed minus x to the power 4 because the powers are lower. So if I plug into here, f of 0 would just give us 0 take away 0, which is 0. F of 3 would give us, well, 3 cubed is 27, 4 take away 3 is 1, so the bit in the bracket is just 1, so that's just 27. Then I'm going to sub in my stationary points as well, so I'm going to plug in, so I've already done my stationary points, what am I saying? I'm going to plug in my endpoints. So I'm going to put in negative 1. If you do negative 1 cubed, then that's negative 1 in front of the bracket, And inside the bracket, it would be 4 minus minus 1. So that would become 4 plus 1. Now that's just minus 5. And then if I plug in my other endpoint, if I plug in the number 4, well, 4 cubed is 64. 4 take away 4 is just 0. So this comes out with 0 again. So what we have to do now is then we just simply look at this and we say, right, what's the biggest number we've got? The biggest number we've got here is 27. So our maximum value is 27. The highest number the graph goes to for this little window that we've got created is 27. And we always write when that occurs, just in case the question asks it. So that occurs when x equals 3. That was our stationary point. Now our minimum value is the lowest number out of our list, which is minus 5. So our lowest value is minus 5 when x equaled minus 1. And that is what we are looking for our final answer. And just to illustrate, I'm going to show you this in the picture. So here is what we've just done here. Now, I wanted the graph from minus 1 all the way up to 4. And then we plugged in our stationary points of 0 and we plugged into 3. And the 3 answers we got are where my red circles are. So the maximum was your 27 when x was 3, and your minimum was your minus 5 when x was minus 1. So just to prove what we're actually doing here, but without a picture, it is a case of stationary points, plug in the x values, end points, plug in those as your x values. I'm going to do one more. So this one here is looking for the stationary points of this function between minus 2 and 1. So we're going to start by getting our stationary points again. So f dashed x would be 6x squared minus 6x minus 12. And then for our stationary points, we're going to say f dashed x equal to 0. So our stationary points, f dashed x equals 0. And I just always write that out of habit. Sometimes just always writing it reminds you of what you're going to do next, because we're all very good at differentiating, but then forget where to go from there. Now there's a common factor of 6, so I'm going to remove that just now. That gives you x squared negative x negative 2 all equal to 0. Let's factorise. So we're looking for two numbers that multiply to 2. Well, it's clearly 2 and 1. To make negative 1 in the middle, then that had to be negative 2 plus 1. So this gives us x equals 2, and this gives you x equals minus 1. Now notice, one of them is no use. So we were only looking for it to be between minus 2 and 1. So this one here is out with. Okay, so it's out with our limits, or out with our endpoints, or out with our domain, whichever you want to call this. So that means I'm only substituting in 3 values here. So I'm going to work out f of minus 1, and then I'm going to work out f of minus 2 and f of 1. So let's start with f of minus 1, the stationary point. If you plug minus 1 back into your original equation, so remember the original equation is this one here. I'm going to take it a wee bit at a time. So minus 1 cubed is minus 1, times 2 is minus 2. So we get minus 2. Minus 1 squared is just 1, so that gives us minus 3. And then minus 1 times minus 12 turns into plus 12, plus 5. Now that would give you, well, I always do the positives first, that's 17 take away 5, which is 12. Next, I'm going to sub in the endpoints. I'm going to sub in negative 2. So f of negative 2, would be, well, negative 2 cubed is 8, doubled is, sorry, it's negative 8, doubled is negative 16, negative 2 squared is 4, times minus 3 is minus 12, negative 2 times minus 12 turns into plus 24, and then plus 5. So if I do the positives first, that's 29, and take away 28, which is 1. And then the last one I'm going to do is I'm going to do f of 1, which is probably the easiest one, so nice to leave that for last. That just gives us 2, take away 3, take away 12, plus 5. So that is 7, take away 15, which is negative 8. So all that's left to do now is your conclusion. So we looked for our highest number. So our highest number was 12, so our maximum value was 12. and that was when we used -1, so when x equals -1. And our minimum value was the lowest number we got there, which was -8. So our minimum value equals -8 when x equaled 1. And that is what they're looking for as a conclusion. So it's actually not that bad. I think where the problem lies with these questions is remembering what to do. So thanks for watching. And then what I've done for my third example, I've pulled out a slightly harder one from a past paper, and I've just thought I'm going to put it in to show you the wording and show how many marks it's worth. Now, this is worth 7 marks. Granted, this is a lot trickier looking than the one I did. So my first thing is I'm going to rewrite that as y equals 6x take away 2. Remember, square root is a power of half, or I always tell my pupils the root is the power on the bottom. So the bottom becomes the root. So the square root means there's going to be a 2 on the bottom of the fraction. So it is that. So let's work through it. So we're going to differentiate. This time it's dy by dx. Don't think any different of it. It's okay. So dy by dx would give you 6 take away. Now if you do 2 times 3 over 2, the times 2 and the divide by 2 cancel out. So that's just 3. Or you could think of it as 6 halves, which is just 3. 3x, lower the power by a half, it gives you, lower the power by 1, it gives you the power of half. Okay, now what we then do is, I'm going to rewrite that as 6 take away 3 square root x. Now remember, for your stationary values, we're going to put dy by dx in this case equal to 0. So we're going to put dy by dx equal to 0. So this gives us, if I'm just going to put my 0 on that side. When you try to solve this, I'm going to take the 3 root x over here, which leaves me with 6. Then I'm going to divide by the 3, which leaves you with root x equals 2. Now that's the square root of x, so I'm going to do the opposite to the other side. I'm going to square the 2, which gives you 4. Right, I'm now ready for the substitution part, so I'm going to change my pen colour. So I'm going to sub in the stationary point first of all. So into my original equation, so into this one, I'm going to work out when x is 4. That gives me y equals, so 6 times 4 is 24. Take away, well, the square root of 4 is 2. Cube it is 8, and then there's a 2 in front, so take away 16. 24 take away 16 is 8. When x equals my first endpoint of 1, that gives me y equals 6 times 1 is 6. Take away, well, the square root of 1 is 1, cube it is 1, times it by 2 is 2, which is 4. And the last one, when x equals 9, you have y equals 6 times 9 is 54. Take away, square root of 9 is 3, cube it is 27, double it is 54. Well, that just gives us 0. So our conclusion for this one is our maximum value. Right, what's the highest on that list? It's 8. So maximum value is 8, and that's when x equaled 4. That was our stationary point. And our minimum value equals 0, and that happened when x equaled 9. So just to show you past paper one, how it's worded, they didn't use maximum minimum, but greatest and least is very much the same. 7 marks for all that. I think that's wonderful. Anyway, thanks for watching. If you are a higher textbook, the National 5 one, page 71, question 2 to 7 have some good examples. I've got a feeling I used question 1 as my example, so that's why I've said to start from 2. Right, thanks for watching.